Hello everyone, in this video we're going to talk about how we can use Pascal's triangle to expand some binomials. So at the top of the screen in yellow we see Pascal's triangle, and what we notice is the first number and the last number in each row are 1, and the other numbers are just the sum of the two numbers that are directly above it. So let's say, for example, we look at this 2 right here. Well, it's the sum of 1 plus 1, so that's where the 2 comes from. 1 plus 2 is 3, 2 plus 1 is 3, so that's where the 3's come from. 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4. So there's where 4, 6, and 4 come from. And then 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 is 5. So we could keep going from there, but we're going to stop right there for this video. So we have 6 rows, but we consider this first one to be row 0 when we're referring to how we can identify and expand some binomials. So let's scroll down here just a little bit and we can see our row number and then what our exponent is going to be on our binomial and how that's going to help us to expand the binomial. So for row 0, we see that n, or our exponent or our degree, is 0, and our binomial expansion is just 1. So we know that anything to the 0 power is 1, and that includes a binomial raised to the 0 power, so that is just equal to 1. So then row 1, we have an exponent of a 1, or n is 1, and so that gives us 1a plus 1b. So notice that the two numbers there, those are our coefficients of our two terms. Okay. So row 2, we have an exponent of a 2, and notice our numbers here are 1, 2, and 1, so our coefficients are 1, 2, and 1. Okay, and we'll talk about the degree on each of our terms in just a minute. So then we go to row 3, and we have 1, 3, 3, 1. So there's our coefficients, 1, 3, 3, and 1. Row 4, we have 1, 4, 6, 4, 1. So our coefficients are 1, 4, 6, 4, and 1. And in this video, we're going to work all the way down here to the 5th row, but this would keep going on if we want to keep extending Pascal's triangle. So we have 1, 5, 10, 10, 5, and 1. So our coefficients would be 1, 5, 10, 10, 5, and 1. Okay, so that's how Pascal's triangle can give us the coefficients of our terms when we expand some binomials. And now let's look at 4 other observations, or 4 observations in total, that we can see from this binomial expansion using Pascal's triangle. So first one says an expansion has n plus 1 terms. So if we start with 0, we're going to end up with 1 term. When we have a degree of 1, we have 2 terms, right? We had 1a plus 1b. So that is telling us that whatever our degree is on our binomial, we should have in our final answer, once we expand it, 1 more term than that degree. The second one, the second 2 refer to our degrees on our exponents on each of our terms. So number 2 says the power of a begins with n, decreases by 1 in each successive term, and ends with 0. So the power of a, so we see our term here a. We notice that we always start with that term, right? And so it says that the power begins with 0, or excuse me, begins with n, decreases by 1 in each successive term, and ends with 0. So essentially our first term will have an a in it, and the exponent will be this same degree that our binomial had, and then we will end, our last term will not have an a. Okay, so let's take, for example, row 3 here. So notice how we start with a cubed, then we're decreasing by 1. So a squared, a to the first power, and then we do not have an a term in our last term. Okay, so now the power of b is the opposite of that. It begins with 0, it increases by 1 in each successive term, and it ends with n. So let's take, for example, the 5th row here. Okay, so notice how we do not have a b term in our first term, and then we go to b to the first power, b squared, b cubed, b to the 4th power, and then we end with b to the 5th power. So that's how our degrees work for each of our terms. And then lastly, it says the sum of the powers of each term is n. Okay, so let's take, for example, our 4th row here. So the terms would be like a to the 4th, 4a cubed b, 6a squared b squared, 4ab cubed, and 1b to the 4th. So the sum of the powers in each term should be n. Well, we're looking at when n is 4. So the sum of our powers should be 4. So we notice in this term, our first term, the only power we see is 4. Then in our second term, we have a cubed and b to the first power, so 1 plus 3 is 4. Our third term is a squared, b squared, 4. Our 4th term is a to the first power, b cubed, so there's 4. And then our last term is b to the 4th, and so there's our degree of a 4. Okay, so those are some observations that we can take from our binomial expansions using the Pascal triangle. So now let's do a couple of examples where we expand, okay? So for number 1, we're going to expand x minus 3 quantity cubed. And then for number 2, we'll expand 2y plus 4 quantity cubed, okay? And so for number 1, I think I might have said cubed. Well, we're going to the 4th power on number 1. So 2 things that I would do to start off. First thing I would do is identify your 2 terms. So you have a and you have b, okay? And let's actually write this over here, okay? So we have a, which would be x, and b would be negative 3. And now we want to identify what our coefficients would be, okay? So now here we have to be a little bit careful because we're not, since n is 4, this is not the 4th row, right? So let's go back up here. It's not the 4th row, okay? When n is 4, we had, actually technically, yes, it is the 4th row, but we're not starting with row 1. That's what I meant to say. Okay, we start with row 0, right, in our triangle. So when we're thinking of our triangle, we're starting with row 0. So this is row 1, row 2, row 3, and row 4. So this is what we're looking at. Those coefficients are what we're looking at for our binomial expansion here. So we've got 1, 4, 6, 4, and 1. So I would go ahead and write that 1, 4, 6, 4, and 1. And so now you're going to use those 3 pieces of information to now expand your binomial. So we're going to start here and we're going to say 1, and we're not using a, so we're going to use x. And remember, our first term is always going to start with the power of our original binomial. So this would be 1x to the 4th plus 4. Now we're going to decrease our powers of x here, so 3. And now we're going to bring in our b term, which is negative 3, and it's going to have a power of 1 there. Okay, now we go to 6. Now we're going to decrease our power of x to a 2, and we're going to increase our power of negative 3 to a 2. Okay, now we go plus. Now we have a coefficient of a 4. We're going to decrease our power of x now to just to the 1st power, and we're going to increase our power of negative 3 to the 3rd power. And our last term, we have 1 as a coefficient. Now our x terms are gone because it has an exponent of a 0, and we're going to increase our power of negative 3 to a 4. Okay, and so now once we've done that, we just got to go through and simplify. So 1x to the 4th would just be x to the 4th. And then we have 4 times negative 3, so minus 12x cubed. Okay, now here we're going to have a plus because negative 3 squared would be 9. 9 times 6 would be 54, so 54x squared. And then we're going to have minus because negative 3 cubed would be negative 27. We do 27 times 4, and that's going to give us 108x. And then lastly, negative 3 to the 4th power would be plus, not 6, plus 81. And that would be our final polynomial expansion right there. So x to the 4th minus 12x cubed plus 54x squared minus 108x plus 81. Okay. All right, now let's take a look at our second example here. So we're going to expand 2y plus 4 cubed. Okay. So let's go ahead and make our note. Let's say, hey, a is 2y and b is 4. And now we want to write down our coefficients that we're going to have in the 3rd row, right? And so remember, we're starting with row 0. So we had 1, then we had 1, 1, then 1, 2, 1. Now we're at 1, 3, 3, 1. Okay, so that should be our 4 coefficients that we're going to use here. And remember, always the numbers that we write down for our coefficients, we wrote down 4 numbers here. It should always be 1 higher than that exponent, okay? All right. So now we can go ahead and write down, we're going to say 1, and then we have 2y cubed, right, because we're starting with our exponent just like on our binomial. And then we have plus 3, 2y. Now we're going to decrease 2y, and we're going to add in 4. Okay. Now we have another 3 as our coefficient. We're going to decrease 2y's exponent again just to a 1. We're going to increase the power of 4 to a 2. Now we do plus, our last coefficient is 1. Now our 2y term has gone away, and we have 4 cubed. Okay, so now we've got everything set up, we've expanded it, and now we can just simplify. So we're going to have to give this exponent to the 2 and the y, so that's going to be 8y cubed. Okay, and now we have 4 times 3 here would be 12, and then we're going to multiply right there. That would be 2 squared was 4, so 12 times 4 would be 48, and that'd be a y. Plus 4 squared is 16. 16 times 3 would be 48. 48 times 2 would be 96y. And then plus 4 cubed would be 64. So that would be our final expansion there. 8y cubed plus 48y plus 96y. Actually, this 48y should be a y squared. There we go. Plus 96y plus 64. And that is how you can use Pascal's triangle to expand binomials.